Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to solve KSET 2025 Physical Science question paper, that is physics question paper, which was conducted today. Okay, let us start with the first question. What they have asked the question which is from the solid state physics. I am solving the D question paper, D series question paper. First question says consider the crystal structure of KBr which is modeled as the set of a touching spheres. Each potassium atom has a radius R1 and each bromide atom has a radius R2. The centers of the sphere form a simple cubic lattice. The packing fraction of this system is, as we know that the packing fraction formula is nothing but volume occupied by the biggest spheres within a unit cell divided by volume of the unit cell. Okay, so in the simple cubic lattice, what is the relationship between R and A, that is the atomic radius, and the side of the unit cell which is represented by the A, R, which is nothing but A divided by 2. So the volume of the unit cell, here we are having KBr, that is a K plus and Br negative, which is the two different radius R1 and R2. So A will be 2 times of R1 plus R2. If I cube this, I'll get the volume. So, and upper side in the numerator, we have the volume occupied by the biggest spheres. That is, the volume of the sphere is what? 4 by 3 pi r cube. It is r cube instead of r cube, r1 cube plus r2 cube. Okay, it will be 4 by 3 pi r1 cube plus r2 cube. Okay, taking 4 by 3 pi common, and a cube, that is the volume, it is 2 cube and r1 plus r2 cube. On solving this equation, we get option 2 to be right answer. Okay, let us move to the next question. In a periodic potential, the effective mass of an electron is related to, this is also from the SSP, that is solid state physics. We have the formula, that is the effective mass, that is m star. Effective mass is represented by the m star, which is equal to 1 divided by d square E divided by d k square. This is the relationship between the m and E and k, and E, that is the energy, and k graphs we have. So I can go with the option B, that is a band curvature in the EK diagrams. That is the right answer. This is also from the solid state physics, and this was the important formula in EK representations of curve, or EK diagrams you can call. Okay, let us move to the next question, that is third question. If the conductivity sigma, which is equal to 5.6 into 10 to the power of 7, and n, which is equal to 8.5 into 10 to the power of 28, and E, which is equal to 1.6 into 10 to the power of minus 19, then the relaxation time tau, which is equal to how much? So the relaxation time, it is given by the formula, that is, we have the formula for the conductivity sigma, which is equal to n e square tau divided by m star, that is the effective mass, or you can call it as the mass of the electron, simply m. So from here I can give the formula for the relaxation time tau, which is equal to, on cross multiplying, that is sigma into m divided by n e square. After substituting the formulas, we get tau, which is equal to, what is sigma? Sigma, that is the conductivity, 5.8 into 10 to the power of 7 into mass of the electron, they have not given, but we should know it is 9.1 into 10 to the power of minus 31 kg divided by, what is n? That is the uh, number density, you can call number density. It is 8.5 into 10 to the power of 28 they have given, into the charge of an electron square, that is 1.6 into 10 to the power of 19 minus 19 whole square. If I solve everything, even the powers and this everything, if I solve, I'll get my final answer to be how much it is. 2.42 into 10 to the power of minus 14. What is the unit for the relaxation time? It is seconds. Always unit should be in small letters. Okay. Yes. Next, when we have the scientist, when we have the scientist name first letter, it will be capital. Otherwise, it is represented by the small letters. Okay. Next, we have the next question, fourth question. So here, which option is correct? It is nearly equal to, it is same to the option C. So option third is the right answer for third question. So I'll go with the fourth question. The AC Josephson effect, it is characterized by, and it is the direct question from the effect. I can see oscillating current under DC voltage is the right answer. Let us move to the next question. A single crystal does not have a five-fold symmetry because it is also a theoretical question. It violates the translational symmetry of the crystal. Okay. Let us move on to the next slide. Yes. What does the sixth question says here? The energy of a two particles in the field of each other is given by energy. It is U, and there is a dependency of R which is equal to minus alpha divided by R plus beta divided by R to the power of 8 it is. Okay, where alpha and beta are the constants and r is the distance between the centers of the particle, the separation r naught between the particles at equilibrium. In the sense, what we need to do in this question means we need to differentiate energy with respect to r, then we need to equate it to 0, then we will get the exact value for r. Let us do that. Differentiating energy with respect to the r, we get on differentiation of r, 1 by r is r to the power of minus 1 divided by r square it will be. So minus alpha into minus 1 divided by r square. Yeah, beta is alpha and beta both are constant. So differentiation of r with respect to r to the power of 8 minus 8 here it will be minus 8 into r to the power of minus 8 minus 1. So it will be minus 8 r to the power of minus 9. So or else minus 8 divided by r to the power of 9 it will be. So beta into minus 8 divided by r to the power of 9, I can write it the differentiation of this. I am equating this differentiation to 0. So what will be minus? My answer, minus of minus, it will be plus alpha divided by r square. If it goes to the right hand side, it will be positive 8 times of beta divided by r to the power of 9. So r square and 1 of the square get cancels. What will be remaining? R to the power of 7 will be remaining, right? So alpha, which is equal to 8 times of beta divided by r to the power of 7, or I can take r to the power of 7 which is equal to 8 times of beta divided by alpha, or r to the power of 7, or I can say r to the power of 7 which is equal to 8 times of beta divided by alpha, or r which is equal to 8 beta divided by alpha all to the power of 1 by 7. This is the value of the r naught. So which option is correct here? Yes, it is 8 times of beta divided by alpha whole to the power of 1 by 7. I can tell here option A is the right answer. Yes. Let us go to the next effect. The defect that does not disturb electrical conductivity of an ionic crystal is. From the definition, I can say it is a Frenkel defect. What the Frenkel defect says means the displacement of an ion to an interstitial site without changing overall charge balance. So from this definition, I can say it will not disturb the electrical conductivity in the Frenkel defect. Okay. During the transition in an indirect band gap semiconductor, they have given four options. In this, momentum conservation requires phonon participation is the right answer. Let us go for the next question, which is also the direct question. Kevlar is an example of lyotropic liquid crystal. Okay. Yes, next we will be moving on to the next question, that is 10, which is again from the SSP. The all voltage of 5 millivolt is absorbed across a 1 centimeter thick sample with current I which is equal to 3 ampere and magnetic field which is equal to 1 Tesla. The carrier concentration, that is carrier concentration, is N. They have asked here what is N. So what they have given the voltage which is equal to 5 millivolt. They have given the thickness, that is T, which is equal to 1 centimeter, and they have given the value of current I which is equal to 3 ampere and the magnetic field B which is equal to 1 Tesla. So from the definition of the Hall effect or Hall voltage, I can call that is VH which is equal to IB, it is the formula, divided by NET. Okay, and the symbols have the usual meaning. From here, what is N? From this formula I can call N which is equal to IB divided by VHE into T. Okay, on substituting the things, the current which is equal to 3 ampere and uh, magnetic field which is equal to 1 Tesla divided by Vh is the voltage. It is given 5 millivolt, that is 5 into 10 to the power of minus 3 volt into charge of an electron. It is we must know the charge of an electron, it is 1.6 into 10 to the power of minus 19 uh, into what is the thickness they have given, how much they have given, it is 1 centimeter. We need to convert into meter. It will be 10 to the power of minus 2 meter. Okay, on solving everything we get the answer. I have solved this and we get the answer to be 0.375 into 10 to the power of 24 electrons per meter cube, because n which is equal to number of electrons divided by volume. So its unit will be electrons per meter cube. So what is the answer? Option C is the right answer for 10th question. Yes. Let us move to the 11th question. An experiment is performed to search for evidence of the reaction, that is proton plus proton gives rise to H plus K positive, that is K meson plus K meson. The values of the electric charge, strangeness and the baryon number of this particle H are respectively. This question is a very easy question. I have done this concept in my YouTube channel also. You can refer. I'm going to solve this. That is proton plus proton gives rise to H plus K positive plus K positive. This is the reaction they have given. What they have given? The electric charge Q which is equal to, I think they have given in the question the reaction is conserved or not. I'll go with the reaction is conserved and I am going to, that is reaction is allowed, and I'm going to solve by taking this reaction is allowed. So the charge of an proton, we know it is positive one. It is positive one. We don't know this. What is this H? I'll give the question mark for this. K positive, it is clearly mentioned. It is having the charge plus one, and it is also having the plus 1. Here also plus 1 charge, it is q it is equal to 0. If q delta q, that is a conservation of the charge, should be equal to 0, means what should be the value of H? The value of H should be 0. We can clearly see the value of H should be 0, that is the charge is equal to 0. First we got charge 0 0. Now we need to see the conservation for the strangeness. For strangeness, we have for proton it is 0, as we know that proton which is equal to 0 and which we don't know. I have written here question mark. And for K positive it is plus 1, and again for K positive it is plus 1. For here, if we have the strangeness on adding these two, it is added normal addition, simple addition, that is algebraic addition. So it will be plus 1, it will be plus 2. What will be the strange for H? It should be minus 2. If it is minus 2 only, we will get that delta S value to be equal to 0, or else it should be minus 1. So the delta S, it should be what it will be, if it is minus 1 also, we will get delta s which is equal to minus 1, but I see that minus 1 is not there in the option, so I'll go the yes, the strange value for h to be equal to 2, and we know that charge, I have explained here, it should be equal to 0. So 0 and minus 2, we have option 2 will be the right answer. Yes, let us solve this also, that is baryon number. For protons belongs to the baryons, it will be plus 1 and plus 1, and for this it will be question mark, and k positive, that is k meson, these are not the baryons. Okay, so it will be 0 for both k positive, these belongs to the mesons, not the baryons, though the baryon number for k positive and k positive will be 0 0. So the answer for this to keep delta b which is equal to 0, h should be equal to 2, that is baryon number for h should be equal to 2. So I get option b or 2 is the right answer. Yes, let us move to the next slide. What is there in the next slide? When a beam of mu negative, that is a muon, is passed through a matter, some of them are captured in electron like orbits around the nuclei of the capturing atom, forming the muonic atom, the radii of the muonic orbits being smaller than by the factor. So I'll go with the option A. So option A is a mass of the electron divided by mass of the muon will be the right option. Okay, next we have the 13th question. The beam of a alpha particle of kinetic energy 5 millielectron volt passes through a tin foil of beryllium 9. The number of alpha particles scattered between 50 degrees and 70 degrees and between 70 degrees and 110 degrees is measured. What would be the ratio of these numbers? So we have the formula for the scattering, that is I have checked it. So the formula is given by n is directly proportional to 1 divided by, it is inversely proportional to sine to the power of 4 theta by 2. I didn't get the clear clarification for this question. So I have considered only one angle, that is 70 degree and 110 degrees, and I have measured the values. So considering theta to be 70 degree, so it will be theta by 2, it is 35 degree. After considering theta to be 110 degrees, so theta by 2 value will be 55 degree. For solving uh, sine to the power of 4 theta, that is 35 degree, and for 55 degree we will get answer nearly it is equal to 0.1 after solving this. So option A will be the right answer. Okay, yes, next, Bream, brimstone radiation is produced by when it is producing, and it is the direct question from the definition. I can see energetic electrons travel through electric field of a nucleus. So travel through electric field of a nucleus, that is option D or option 4 is the right answer. Yes, let us go for the next question. What does the next question says? What is the de Broglie wavelength of a protons, that of a alpha particles, if both have the same kinetic energy? Yes, we have the formula. Using that formula we can solve this question. So what does the formula says? That is wavelength which is equal to h divided by square root of 2 times of mass into kinetic energy. This is the relation between the wavelength and the kinetic energy. H is the Planck's constant, m is the mass of the electron, mass of the particle. It can be electron or it can be alpha particle. So using this formula I can say, and they have given one more thing, it is having the same kinetic energy, means I can solve this question by uh, that is wavelength of the proton which is equal to h divided by square root of 2 times of m of, that is mass of the proton into kinetic energy, all divided by wavelength of the alpha particle, that is all divided by h divided by square root of 2 times of mass of alpha particle into kinetic energy. Kinetic energy is same, that is kinetic energy of a proton, which is equal to kinetic energy of the alpha particle. So I can cancel these two, and I can cancel h, even I can cancel square root of 2. What is remaining? That is a lambda of p, that is lambda p divided by lambda alpha, that is wavelength of a proton and the wavelength of the alpha particle, which is equal to, it will go to the numerator, square root of m alpha square root of m proton. So that is equal to m alpha, how much they have given, square root of 4 times of u, that is atomic unit, it is u divided by square root of 1 u. So it will be 2 times of square root of 2. Square root of 4 will be what, it is a square root of square root of 2 4, it is 2. So 2 is the right answer, and square root of 1, here it will be 1, and the units get cancelled. So what is the ratio? We have the ratio to be 1. So option 4 is the right answer. Yes. Let us move to the next question. Out of the following, which one of the rays can pass through a concrete slab of 20 centimeter thickness? It can pass through a gamma rays as well as x-rays. X-rays, it is not given in the question, so I'll go with the option C. Next, which quantum number combination for two nucleus leads to maximum attraction in the nuclear potential? For this, S here represents the spin, T represents the isospin, or you can call the isospin representation by I. L is the angular quantum number. Okay, so S, which is equal to 1, and T, which is equal to 0, and L, which is equal to 0. If these three is obeyed, then I can say the quantum number combination for this combination for two electrons lead to the maximum attraction in the nuclear potential. So option 2 is the right answer. Is the final question for the today's video. The theoretical condition for symmetric spontaneous fission on the basis of liquid drop model is. So this is also the direct question. For liquid drop model, the theoretical condition for symmetric spontaneous fission, that is z square atomic number divided by atomic mass, the square of the atomic number divided by atomic mass, it is nearly equal to 15.55. So from this options I can conclude that it is less than 17.6, because 15.55, it is less than 17.6. So I can go with option 2. Thank you everyone.